Okay, so we're going to estimate proportions, and I will show you how to do it when we use the mean. The first thing you must know is estimating the proportion of units in a population that have a particular characteristic is what we're interested in. We know how to estimate means, we know how to estimate totals, but it's now the other parameter, the proportion of a particular kind of unit in the population that we're interested in. You can look at the book, Law Example 2.7, and there they're interested, out of the 3078 counties, what they want to know is what proportion of counties have fewer than 200,000 acres of land under farming. So they've got 3078 farms, they've got how much of each county has, how many hectares is under farming for each of the 3078, and they say what proportion has got less than that. How do they do it? They resolve, so they say we want to work out of 3078 counties, what proportion is less than 200,000 acres of land under farming. But they can't look at 3078, they're going to draw a sample of 300 and use that sample information to estimate the true amount. So it's just about estimating the population proportion using the samples data. So the thing we're interested in is estimating the proportion. And the way we're going to do it is to look only at the sample. So what we want to know, we want to know how do you find your estimated proportion and then the variance of the estimated proportion, but we always estimate the variance because the variance is going to have an S squared or whatever in it, and we don't have all the values of the proportion. So we always use the estimated variance. And the example we're using yet again, you haven't missed anything, is 3078 farms or county areas, you can think of it as farms, and we're saying we pick 300, we want to know out of these, what proportion out of all of them have got very little farming, meaning less than 200,000 acres under farmland. And the way they're going to do it, they're going to have these ones, information, we want to estimate about those. So you really want to know what proportion of these counties have got small amount, less than 200,000 farming. It could be half, it could be quarter. We want to know how to do that. But we know from our previous studies, we're always 95% sure that our parameter of interest at theta is an element of the estimate plus or minus twice the square root. But what we don't know at this stage is what this is and how we use that. When we're using A, we don't know what this is. We don't know what the formula is to work this out or to work this out for our proportion, and that's what this next thing is about. So we're looking at the proportion, and we're 95% sure we know that the true proportion will be whatever my estimate is, plus or minus twice the variance. I'm just replacing my theta by a p, meaning proportion. So we've got to find out how to estimate this and how to estimate this. And it's actually very easily shown, but I best demonstrate by example. We want to show, for example, in class here, what proportion of students have never failed a module in a class of, say, 36. I just made up an example, then I'll go back to the 3078 farms. And what we're saying is there's a class of 36. We want to know what proportion of people never failed a module. How would you find that out? You would say, what is the number in the class who have never failed a module? And then divide it by 36. If it's 18, then you would say, oh, half of the class. Okay, you can all figure that out. Now, the way to do it is to say why I is 1 if you never failed the module, because you've got to look at what you're asking. Like the example I did just now about the girls. The girls were 1 because I said, what proportion of the class is girls? In the example I did here, we're saying what proportion never failed. So you give a 1 to everybody who never failed. So for each element, they either a 1 or 0, you recode it, but 1 for the proportion you're wanting, never failed, 0 elsewhere. By doing that, if you found the mean, you would add together these y values and you would add together everybody who never failed, which in the end will be how many never failed divided by the total. And that will obviously be, in the end, exactly what the proportion of class is. So the beauty of this, and this is the first time I saw this was a sample survey, I thought that's so clever. Why is it clever? I want to find a proportion P. And by recoding with a 1 and 0, I can actually just find the Y bar. And you already know how to estimate a Y bar. That's what you did in your last test. So as long as we can find, so we can find P as long as we know how to find Y bar. And Y bar is just the average of the 1s and 0s. You recode your data in your sample. So we say it's a 1 if it's got the desired property. Desired property means the thing I want proportion of females, then 1 is female. Proportion of small farms, 1 will be if it's a small farm, and so on and so on. So why is it a big deal? We can use all the previous theory. So you already know this. You already know this, right, from our previous. So now I'm saying we're going to do exactly the same, but instead of Y bar, you already know how to do T. We're now putting proportion P. So how do we do that? And instead of a Y bar hat, I've got a P hat. Variance of Y bar hat, theta is now P hat. Can you see? It's very simple. First thing you must know, if you want to estimate the population proportion, you estimate the sample proportion. Why? Because it comes from this. If I want to estimate the population mean, I just use the sample mean. It's the same thing. You want to estimate the P, which is really just a mean. The population mean you estimate with a sample mean. The mean is the same as a proportion, so that when you use the 1s and 0s, it just becomes a proportion. The proportion becomes a mean. I can rewrite this as a mean. It's estimated by the sample mean. So this P is the same P, it's a proportion, but it's of the sample now. So we say, if you're using without replacement or if you use with replacement, you estimate the population proportion with the proportion of the sample. So if I drew a sample out of the 36, if I drew 5, I just say, what proportion of my sample is female, if that's what you're interested in, and then you say, that's my estimate. To get the variance, I can very easily prove it to you, and I've put the P's and I put a blue over it so that you know these P's are actually population values, it's not the sample values. Just like here, you had a big S and a big S, this is the proportion in the population. So you can rewrite this very easily, by the way, to prove it in this way. But you don't have the population's proportion, so that's why you're trying to estimate it. So that's why you've got to estimate the variance, because this is population values and you don't have it. So we actually, in the end, use these values. So what it's saying is, if I want to estimate the population proportion, you use this, and I use simple random sampling with replacement, say. I estimate the proportion in the population that is, say, female, by looking at my sample what the proportion is. If I want to know how much does it vary between samples, I use this. Proportion 1 minus proportion divided by sample size minus 1. If you're using without replacement, you use same, the proportion in the sample divided by that. Can you see? Very simple. You don't have to remember it off by heart. You'll get a formula sheet. I can ask you to prove it because it's really simple, but I'm not spending this year. We're doing concept-driven teaching. So I'm just going to give you those, but you must know how to do it. And the reason why I've put this here, because it's hard to see which P of mine is big and small. So the ones with the blue are population proportions. All the other, that P, that one, and the P's here are sample values. So the big P with the blue over it is the population parameter. Population proportion, in other words. Okay. Now to demonstrate how to use it, we go to law example 2.7. They said we're interested in knowing what proportion of all the 3078 counties have fewer than 200,000 acres of land. And that data set has got, like this one, has got 3 million, 4.8 thousand, whatever. They're saying what proportion has got, what proportion of the 3078, with other words, in the population, has a number attached to it that's less than 200,000, because that's each county had how many acres of farmland under it. And what they did, they selected 300 farms, you know that by now, and they're saying out of those 300, so the question is, out of these 300, what proportion had less than this farming? And say it's half, then I will say, oh, I estimate it's half for these as well. because whether you're doing with or without replacement, you need to know that from the previous grid, you can just use the proportion in the sample to estimate the proportion in the population. So we have to recode. We say YR is 1 if it's got less than 200,000, 0 elsewhere, and then it's really just to connect. You don't redo your, you can actually use a replacement rule in Excel. You can put a new column in and make them 1s and 0s and just add up the 1s and 0s and divide by 300, and that will give you a sample proportion. But we found out of the 300 selected farms, 153 had less than 200,000 acres of farmland. So out of the 300, 153 had less than 200. So what is the proportion in my sample of 300 that had less than 200,000? It's obviously 153 divided by 300. That's my proportion in my sample with less. So out of the 300 farms in my sample, 300 counties, 153 of them had less than 200,000 acres under farmland. So that's 51%, or 0.51. So we can say in the sample, 0.51, just over half of the sample had less than 200,000 acres of farmland. But now we say because the sample proportion estimates the population, we think also that out of the 3078, about 0.51 proportion or 51% has less than 200,000. So we estimate proportion of farms with less than 200,000 acres of under 200,000 acres of farming land is 0.51. That's a point estimate for the 3078 farms. But we now want to give a confidence interval. How do we do that? We do it like that. Where did I get this from? You've got to go back to, let's quickly go back to this. If I use without replacement or I use this, the standard error would be the square root of this, right? So you just go right back to your grid and you see what you'll see that this is for simple random sampling without replacement. This is our estimated variance is the bottom, so the estimated standard error is the square root of that. So you're just going to substitute in the values, 1 minus sample size divided population size. We've just seen the proportion in the sample is 0.51. You substitute the values in and you get that value. So this is the standard error. So therefore we say we're 95% sure that the true value of the proportion of counties with less than 200,000 farming land is P, which is 0.51 plus or minus 1.96 or 2, it doesn't matter. The standard error comes in there and you work it out to be between this and this. So what it's saying, in my sample of 300, we selected 300 out of 3078. We found that in the sample, we found that 0.51 is the proportion of counties with less than 200,000 acres of farmland. We know it's 0.51. But if you want to give a confidence interval, we can say we're 95% sure it's between 0.455 or 45.5% and 56.5% of all of the 3078 have a proportion, that's the proportion with less than 200,000 acres of land under farming. So you can see how we use the sample proportion to estimate the population proportion, and we can give a confidence interval. It's very, very simple. Once you've got the basic idea, as theta changes, you just look up in your grid, what do you estimate? You estimate the population parameter is a P with a samples P, and then what's important is to get the formula right for the variance and take the square root for standard error, because always it's theta hat plus or minus 1.96 square root of your variance. And it's a different variance for every formula. We're still going to do stratification where the formulas change again. So there are lots and lots of different formulas. You must just be sure what type of sampling did you do. Am I estimating the mean, the total, or the proportion, and so on. Now just a deeper thought I want you to think about. With the confidence interval for proportion of farms with less than 200 acres of farmland with them be wider or more narrow if I used with replacement sampling? So what do you think? It's basically saying what is more accurate, with or without replacement. Think about it. I've got 3078 and I pick 300. If I use with replacement, I put some back and I can pick them again. There's one with a big lot of farming. Can it skew your data? Can it give you bias if you replace? What do you think is better, with or without replacement? What's intuitive? Without, okay? Without must always be better because you've got 300 different values. If you're replacing, there could be one with lots of farmland and you took it twice. Then it's not as right. It's not as fair. So let's quickly look at the formula. You must look. That's why when you can't, it's not a 50-50 guess. If I say which one will give you a smaller confidence interval, what's your confidence interval? You know it's your estimate plus or minus twice the square root of the variance. Where's the variance? I'm estimating proportions. This is without replacement. This is with replacement. That's the variance formula. So I want standard error. It's theta hat plus or minus twice square root of variance. The error comes from the variance, from this and this. Now if you look at this, P1 minus P over N minus 1, P1 minus P over N minus 1, it's the same. What's multiplied? 1 minus N over N. Does this make it bigger or smaller? Why? What's the biggest it can be when you have a N equal to big N, and that will be like 1 minus 1. If you take the whole population, because then there's no variation, it's a constant. But suppose you sample half of the population, N is half of that, that would be, that's like 100, that's 50, that would be half, this would be a fraction, so it's making this thing smaller. Generally, 1 minus N over N must be a fraction, because if you sample, say, your sample is, say you've got a population 3078, and you take half of it, 1 minus a half will give you a half, so it's saying this number will always be smaller than that one. This variance for without replacement has to be smaller than with replacement. So your confidence interval is theta hat plus or minus twice square root of the variance. So the thing that stretches it is the variance. And unless you can argue like that, if I say in the test, the next test say, I'm estimating proportions, explain why the confidence interval is wider if you use with replacement. Is it, or I say, is it or is it not? You must be able to say, okay, that's the formula, the confidence interval plus or minus twice the square root of the variance. The variance is always going to be bigger for with replacement than this. You can't just 50-50 guess, yeah, it's smaller or it's bigger, but you can't look at the formula and explain why. It's very important, and if you're having problems doing it, many of you got 4 out of 20 and 5 out of 20. It's generally because you can't look at a formula and make an argument. You must be able to do that, because remember, I'm not asking you to prove the formula. Last year, look at the exams, they proved the formulas. You might feel more comfortable proving a formula. But when you're working in industry, you can't come there, let me prove it for you, but I can't use it, but hell, I can prove it. Not going to get you anywhere. I can prove it for you, but I can't use it. They're not going to employ you. You must be able to say, should we do with or without? And you'd say, I would rather use with replacement without because of, and you can show the formula. You see, this is why this would give you a more narrow confidence interval. That's a much better argument. But if you can't make that argument, and I'm not going to ask you to prove it, then you've got to at least understand the formulas, because I'm giving you the formula. I can't give you a mark for looking on the sheet and taking the same formula and writing it down if you can't explain what it's doing. So please be clear, and don't feel bad if you can't do it. I'm sure when I was your age, I couldn't do it, because that's not the way you were trained at school. At school, you were taught how to learn off by heart and how to regurgitate. I was taught like that as well. And it's fine, but we have to get out of it if you want to be useful. And if you're having problems with it, no problem. Just come and ask me, and we'll spend a few minutes together, and then you'll be better. So let's just go back to where we are. Time on that. Okay, so in this case, we saw the 95% confidence interval is between 0.455 and 0.565. So the real answer was the population proportion is estimated by sample proportion of 0.51. The answer was 0.51. You'll see the P there. So the sample proportion is 0.51. We're saying in the sample, the proportion of farms that have less than 200,000, county areas with less than 200,000 acres of land is 0.51. Even though I know that's a single, but you know what? I'm 95% sure it could be a little bit lower or a little bit higher, but it's between 0.455 and 0.565. You'll see 0.55 is right in the middle of that. Can you see the idea? And what we're saying, with other words, this was for without replacement. If you use with replacement, the confidence interval would have been wider because the variance is bigger. And you must understand that. So 95% sure that it's between there and there. If I say use with replacement, it would be a wider interval, so it will be like say 0.41 and 0.58. It will be wider, less accurate. So you must be able to make that one. The next one, note that standard error of your proportion has a P and 1 minus P. Have you ever thought about it? P and 1 minus P, suppose P is a half. It's a half times 1 minus a half, it's a half times a half. If P is a half, what would this be? What's P times 1 minus P if P is a half? Quarter. Come on, you should know that P times 1 minus P would be a half times 1 minus half, it's a quarter. If you took, do you know the biggest P times 1 minus P could ever be is for P is a half? Any other value will give you a smaller value. Because if you took a third, 1 minus a third will be 1 third times 2 thirds is 2 over 9. The biggest this is if P is a half. So what's bad about that? Your standard error formula has got a P times 1 minus P in it. Yeah. P near a half is bad news. What was our P here? 0.51. It's near a half. That's bad. Any P in your sample that's near a half should be bad for you because P times 1 minus P is in the formula of the variance. And a P near a half is going to make your variance big. You can't change it. It's just true. So what you have to do if you want to make your confidence interval smaller is what? That's going to be big. The only thing you can do is to make, you can't change the n. The only thing you can do is make your n bigger. So that's really important. If ever you see you have a P in your, that's near a half, in this case 0.51, you must look, if your confidence interval is wide, just increase your n. So the only thing you can do in this case, what can we do? Increase your sample size. That's the end of today's class.